Hey everybody, I hope 11.3 has been going well. I wanted to provide some examples and help with the last topic in the section, annuity problems. And there's some definitions in the theorem and Canvas. What I want to show is like how we got that formula in the theorem. It's going to be based off the fact that the amount of the annuity is the sum of all the deposits made plus all the interest paid. And let's suppose that we're just making 5 deposits. Sometimes I see it's easier just to play with numbers instead of all the variables. We still know that I is the interest rate divided by the number of times it's compounded. I think the confusing part is just the deposits made. So if we're going to have 5 deposits made, the tricky part is that the first deposit is going to be a payment is the interest compounded for 4 payment periods, so that 5 minus 1. So in other words, for the first deposit, the amount is going to equal P times 1 plus I to the 5 minus 1, or 4. And the second deposit is going to have a payment period of n minus 2, so we're saying P times 1 plus I to the 3, and we're going to continue till we make the 5th payment, or 5 minus 5. So we'll have to the 1, and then P times 1 plus I to the 0. This is going to cancel to 1, giving us our P. So looks a little backwards, but this is what the annuity would be for 5 payment periods. And so hopefully this looks a little familiar. Let's begin by factoring out a P, and I'm going to rewrite this as 1 plus I plus 1 plus I to the 2nd plus 1 plus I to the 3rd. Gosh. Plus 1 plus I to the 4th. And hopefully you recognize this as a finite geometric series with 5 terms. In this case, our initial term, or A1, is P, and the rate, the constant factor growth, is R equals the 1 plus I. And there's 5 terms, so then n would be equal to 5. But at this point, hopefully you can extrapolate this to if n was just made n deposits, maybe 30, or varies, right? And so what we can tell is that when we have that finite geometric series, we can express the sum as A1 times 1 minus R to the n over 1 minus R. And so we'll do that in general for our problem. So what we'll say is, so for n equaling n, right, for n payment periods, we'll have annuity will equal P times 1 minus 1 plus I to the n over 1 minus 1 plus I, and the denominator becomes negative I, I to the n over negative I, and then we can rewrite this so that it's P times 1 plus I to the n minus 1 over that I. And so that's how we get that formula that's in the notes on Canvas. Let's look at the next problem that I wanted to work on. So suppose you want to purchase a home and you decide to invest $400 per month into a mutual fund. If the per annum rate of return of the mutual fund is assumed to be 10% compounded monthly, how much would you have for down payment in 3 years? And so what we're seeing is P equals 400. I is equal to 0.1 over 12, which is equal to 1 over 120. And we have, how much will you have for a down payment in 3 years? This is, everything's based off monthly, so then that means that n is going to be 36. And so this means that our annuity, the amount of annuity, is going to be 400 times 1 plus 1 plus the 1 over 120 to the 36 minus 1 over 1 over 120. Alright, so when we clean this up, I'm seeing this 400 divided by 1 over 120 as 400 times 120, so that comes to 48,000, and then this will be times multiplied to the quantity 1 plus 1 over 120 minus, oh, come on, pen, to the 36 minus 1. And so now I'm just going to bust out my calculator, and I'll end up getting 16,712 and 73 cents, just rounding it to the nearest hundredth. And so make sure that when you do these computations, like, I find it helpful to simplify the numbers outside. This is a product all here on top, so you want to find this numerator and then times that by the your outside number there. All right, I hope you found this helpful, and keep working hard, class.